Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Hey Jealousy by Michael Lefkowitz, and that's a reference to a song that was going around that when I grew up. I don't even remember who the actual artists were, but I don't know, sort of nostalgic for me because sort of talking about sort of the freedom that we had, I guess. I don't even understand why what the Hey Jealousy part of it was though. Um, we could ride around this town. Let the cops chase us around. Past is something. And then it's hey jealousy. I don't know really why we're jealous of something or what's jealous of us or who we're jealous of or whatever. But anyways, that was the name of a song that was around when I was growing up. Anyways, let's get to the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have selfish arrows, where a digit on the gray split arrows indicate how many cells in the indicated direction equal itself, including the cell it is. So we're always going to have 1, which is the same as itself, right? Because this is always going to be the same as itself. And then also in this indicated direction, for this arrow specifically, how many cells match this cell? So that's, for example, if we had 3 here, we'd have to have, in addition to this 3 here, we would have to have 2 other 3s on this diagonal. So you could have 3 here and then 3 there, and that would satisfy that selfish arrow. Because there are 3 3s in this direction that equal the digit that's on the arrow. And we also have envious arrows, where the digit on a green arrow with eyes indicate how many cells in the indicated direction do not equal itself. So this would say that 3 digits here do not equal the 3 that is on this arrow. So we could have something like 2, 6, or 9, or whatever. As long as we don't have a 3 on this diagonal, that would satisfy the 3 cells looking this way for the envious arrows. Because these cannot match, or you have to have 3 cells in this direction which do not match the 3 that would be here if that were the case. So that's how envious arrows work. And since we have selfish arrows and envious arrows, I guess that's why we have jealousy? I don't know. Anyways, well, envious is also sort of a synonym for jealous, so that would work there. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so this, again, the ones that can be the same, we have 1 box here, 2, 3 boxes. So this is at most 3 of the same digit. This has itself 1, 2, 3, 4. So this could be up to 4 here. This could have 1 or 2 because we have 1 in the same box here and then this digit. So that's 1 or 2. And this could be 1, 2, or 3. So this is 1, 2, or 3 there. This has 1, 2, or 3 because 1 in that box here, 2 in that box here, and the second, third one there. This could be 1, 2, 3, 4, or 5. So up to 5 there. This is 1, 2, 3, 4, or 5 here. Okay. This could only have one. So this is obviously the same as itself. This could have 1 or 2 digits here that are not the same as itself or not equal to itself. So now we have a 1, 2 pair in row 7, which eliminates 1 and 2 in the rest of the row. So this can't be 1 or 2, it's 3. That means this can't be 1 or 2, it's 4 or 3, it's 4 or 5. 3 must appear on this diagonal 3 times. So we have 1 here guaranteed, 3 here, and then then a 3 on this diagonal here. That eliminates 3 in the rest of those boxes, so this can't be 3. That's a 1, 2 pair there. This sees 1, 2, 3 up to 6. So this cannot be 3, it's 4, 5, or 6. Because only 2 of these digits on this diagonal can be the same as it, so it has to be 4 anyways. This is either 1 or 2, because it sees only 1 or 2 cells. This cannot be 3, so this also has to be 1 or 2 on this diagonal. It can't be 1. So if this cannot just see 1 digit that is not equal to itself, right? If it has 1 digit, that means 2 digits on this diagonal are equal to itself, and therefore that would be a repeat in the box, which is not allowed. So this must see 2 cells that are not on this diagonal equal to itself. So 2 has to be somewhere here, and the other so that means this can't be 2 here. 2 eliminates 2 here, so that's 1. That eliminates 1 in the rest of the row. So 1 sees 1 digit here that is not equal to itself. And therefore, 1 has to be on this diagonal here. Okay. Well, we have a 1, 2 pair in column 6, which eliminates 1 and 2 in the rest of the column. So where is the 1 on this diagonal? It has to be here. This sees 3 or 4. If we try to see 3 here, digits that are the same as 3, this can't be 3 because of 3 in the box. This can't be 3 because of 3 in the column. So this cannot see just 3 cells that are the same. This must see 4 cells that are the same. Well, this is not going to be the same, so this must be 4 there. And we need 4s along this rest of this diagonal, so we have to have a 4 here, and one of these is a 4, which means this can't be 4. We have to have a 4 here, so this can't be 4, this is 5. So 5 on this diagonal must be in each of the boxes, so 1, 2, 3, 4, and 5. So that's 5, that's 5. One of these is a 5, one of these is a 5. Can this be 2 digits that are not equal to it? No, because we have at least 1 and then 2 more here. So this cannot be 2, which means this must be a 2 here. 2 eliminates 2 here, so that's 1, which makes this 2, which eliminates 2 there, so that's 1. So this sees 1 in this direction, including itself, which is itself. This sees... cannot be 5 digits. It can't be 1 or 2. This has to be a 3. So in this direction, it sees 3 digits, which are not equal to itself. That's 1 here and then 2 digits here. So one of these must be a 3 there. How many digits can this see? Up to 1, 2, 3, 4, 5, 6. So this is 5 or 6. How many does this see? 1, 2, 3, 4, 5, 6. So this is 5 or 6 also. Well, we have a 5, 6 pair here, which eliminates 5 and 6 in the rest of the column. So no 5 here. This is 7, 8, 9, 7, 8, 9. Where is the 5 on this diagonal? Here in box 6, it must be there. This sees 1, 2, 3, 4, 5, 6, 7 at most. So it could be 2, 3, 4, 7. This sees 8 on the diagonal. So 2, 3, 4, 8. No 2 here because of 2 in the row. No 3 here because of 3 in the row. This 5, 6 pair eliminates 5 and 6 in the rest of the box. This 4 eliminates 4 here. So we see 2 or 3. 5 eliminates 5 here. Can this see 4 cells that are not 4 then anymore? The answer is no, because we don't have a 4 available here, guaranteed. So these 3 are not 4. That's another one that's not 4. And one out of these 2 definitely has to be not 4. So this cannot be 4, therefore this is 6, which means 6 cannot be on this diagonal. How many digits does this see? 1, 2, 3, 4, 5, 6, 7. So up to 7. Can this see 2 digits that are not? No, on this diagonal. No. Can this see 4 digits that are not 4 on this diagonal? No. So this has to be 7 then, right? 2, we already see 3 cells that are not 2 on this diagonal, so that's not going to work. 4, we see 1, 2, 3, 4, 5 cells that are not 4, so this can't be 4, therefore this is 7. Can we see 3 cells? We already see 4 cells here that are not 3. We see 5, at least 5 cells that are not 4, because these can't be 4 because of 4 in the box, so this has to be 8. So we don't have 7 or 8 on this diagonal. We could have 1, 2, 3, 4, 5, and 6 and 9. But this can't be 1, 4, 5 because of 1, 4, 5 in the box. This can't be 6 here because of 6 in the box. These can't be 6 because of 6. This says 6 of these digits are not 6 in this column. 3 can't be here because 3 has to be on this diagonal to satisfy this selfish arrow. This can't be 2 because of 2 in the column, so this must be 9, which eliminates 9 in the rest of the box. This is 7. It cannot... Can it be 1? No, because we have at least 2 digits that are not 1 here. 2. Can it be 2? This sees 2 digits which are not 2. So this cannot be 2, because if it were 2, it sees those 2 digits which aren't 2, and one of these at least is not 2. So is that one. So this can't be 2, can't be 3 because 3 has to be on this diagonal. So it could be 4, can't be 7 here because of 7 in the row. Can't be 5 because of 5 in the box. So this is 4 or 6. Well, 4 cannot appear here. So that's 1, 2 digits because 4 has to appear on this diagonal here to satisfy this selfish arrow. 1, 2, 3 non-4s, 4, 5 non-4s. So this can't be 4 then. It must be 6. So we see 1, 2, 3, 4, 5, 6, 7. So one of these has to be a 6, but we don't know which. Okay. This can't be 2 here. Remaining digits in row 7, we have 4, 7, 8, 9. 4 obviously can't be here because of 4 in the column. We don't know about these, though. Hmm. 5 eliminates 5 here, so that's 6, which makes this 5. 5 eliminates 5 here. Where's the 5 on this diagonal, which has to be there? It has to be there. So this 6 does not see any 6s on this diagonal. This can't be 6. It can't be 7 because of 7 in the row, so this is 8 or 9. This sees 5 digits, which are not 5. Well, this can't be 5 because of 5 in the column. Can't be 5 because of 5 in the box. Can't be 5 because of 5 in the row. Can't be 5 because of 5 in the row. That's already 5 cells that can't be 5. So therefore 5 has to be here. Which means this can't be 5 there. Where's the 5 in column 4? Can't be here because of 5 is in the boxes. Can't be here because of 5 in the row, so 5 is there. That means we have 8 5s. We know where the last 5 has to be. It has to be there. Okay. This sees 2 or 3. That are the same. If it's 3, it could be 1, 2, 3. Or 3 could be a lot of them. If it's 2, 2 cannot be here. 2 cannot be here. So 2 would have to be there if that were the case, if this were 2. Remaining digits in box 9. We have 2, 3, 4, and 9. There's no 2 here because of 2 in the row. No 3 here because of 3 in the row. Also, 3 eliminates 3 from being here because of 3 in the row. 4 eliminates 4 here. Where is 3 in column 2? Cannot be here because 3 has to be one of these 3s on the diagonal. Can't be in here because 3 has to be one of these 3s on this diagonal, which means we have a guaranteed 3 here in column 2. So this can't be 3 there. This can't be 2, so 2 is one of those 3. That's not helpful. Remaining digits in box 2, we have 6 through 9. This can't be 6, 7, or 9 because of 6, 7 in the row and 9 in the column. So this is 8, which makes that a 9 there. So this can't be 8 or 9 here because of 8, 9 in the box. So we have a 6, 7 pair in column 6, which eliminates 6 and 7 in the rest of the column. So that leaves us 3, 4, and 8. This cannot be 4 because of 4 in the box. So we have 3, 8 here. This is 3, 4, or 8 there. Remaining digits in column 4. We have 3, 7, 6, and 7 left. 6 cannot be on this diagonal because this must see 6 cells which are not equal to itself. So that's 6 there. No 6 there. This can't be 3 because 3 has to be on this diagonal here. Remaining digits of box 5 are then no 3. It's 2, 6, 7, 8. 1 cannot be on this diagonal here because we already see itself. So 1 has to be one of these 3. This is 9, eliminates 9 in the rest of row 2. So the remaining digits in row 2 are 1, 2, and 4. We have a guaranteed 1 there. 9 in box 3 has to be one of these two. That eliminates 9 in the rest of the column. Hmm. 2 has to be one of those two. Two cannot be here. Six cannot be here, cannot be here, cannot be here. So we are guaranteed one of these two digits is a 6 here on this diagonal. So that means we have 1, 2, 3, 4, 5 digits here that aren't 6 and the 6th one here. So we cannot have 6 anywhere on this diagonal. Okay, is that helpful? I don't really know. Where is 6 actually? 6 here eliminates 6 here, so that's 7, which makes that 6. So that's helpful. Remaining digits in row 1, we have 3, 4, and 9. 3 cannot be here because 3 has to be one of these two cells here on this diagonal. Row 3, remaining digits, we have 2, 3, 7, 8, 9. So 3 again has to be one of those on the diagonal. This digit cannot be 6. So it's 1, 3, no 2, 4, 5, no 6. It could be 7, 8, or 9. This can't be 6 here. Can't be 2 because we need two digits that are not 2 here. Could be 1. Can't be 2, can't be 3, could be 4. Can't be 4 because one of these has to be 4 here. Can't be 5, can't be 6. So it's 1, 7, 8, 9 there. Can't be 7 or 9 because of 7 in the column and 9 in one of these two cells here. 7 also eliminates 7 there. Okay. Okay, so which ones are done? This is essentially done. We have all 4 4s. 3 3s, that's essentially done. 6 6s, that's done. 6 non-6s, that's done. Well, technically not, because we don't have anything, and we don't have these filled out. Same with these, well, 5 is essentially done. 7 and 8 are done. 1 is done. 2 is done. 1 is done here. 3 is done here. 2 is done there. 5 is done here. 1 is technically not done. This cannot be 1. Right, this can't be 1 because it would see another 1 in the diagonal. So that would therefore not be 1. It can't be 3 because we don't have 3 3s on the diagonal, so this must be 2. So this is 2, which makes that 3. This must see 2 cells on the diagonal, which makes that a 2. That means this can't be 2 there. 2 eliminates 2 in the rest of the box here. 1 again cannot be on this diagonal, so where's 1 in box 7? It has to be one of these two digits, which eliminates 1 in the rest of the row. So this can't be 1 here. That's 8. That means this can't be 8. That's 4. So this can't be 4 here. 4 eliminates 4 in the rest of the row. 8 eliminates 8 in the rest of the box. So this is 7, 9 as a pair, which eliminates 7, 9 in the rest of the column. So this can't be 7 or 9. It's 8. So this is satisfied here. That's these 2 2s. 6 is satisfied. 1 is essentially satisfied since we know 1 is one of those two. So we need this. This cannot be 2 now because none of these can be 2. None of these can be 2. So this has to be 3. And we do not see a 3 here. We could see a 3 here, or 3 there. But if we can't... Okay, where is the 3 in row 5? Can't be here because 3 has to be on this diagonal here and here. So 3 has to be one of these two, which is not on this diagonal. So the remaining digits that can be 3 on this diagonal can only be here and here. So this must be 3 here, and that must be 3 there. This can't be 3. It's 4, 8 as a pair. 8 eliminates 8 here. So that's 4, which makes that 8. That means this cannot be 8 there. 4 eliminates 4 there. Where's 4 in box 7? Can't be here, can't be here. It must be here. Okay, 3 eliminates 3 here, so it's 7. That eliminates 7 there, so it's 6. This can't be 6 or 7, it's 8. 3 eliminates 3 here. Where is 3 on this diagonal? It has to be there. Okay. 4 eliminates 4. 3 eliminates 3 in the rest of the box. Also, this can't be 4 because of 4 in the column. Therefore, that makes that 9. This can't be 9 or 3. It's 2. This can't be 2. It's 4. That eliminates 4 in the rest of the row. So this is a 1-2 pair. 9 eliminates 9 here. So this is 4, which makes this 3. This can't be 3. That's 3 in the corner. We celebrate because we're close to solving this. 2 eliminates 2 in the rest of the row. This is 3. That sees 3 cells there. This has to be 1, 7, or 9 here. 2 eliminates 2 here, so that's 1 and 2. Okay. 3 eliminates 3 here, so where's the 3 in row 5? It has to be there. That gives us 9 3s. Do we have enough 1s? Probably not. No, we don't. 1 has to be one of these two there. 1 can't be here or here, but could be any of those. 2s. 2 in row 6 cannot be here because of 2 in the boxes. Can't be here because 2's in the column, so 2 has to be there. That gives us 8 2, so we know where the last 2 is. It's there. We have all 9 3s. We have 8 4s, so we know where the last 4 has to be. It has to be there. 5s. We should have 9 5s. We do. 6s. We don't have enough information. Actually, we do. This has to be a 1. Well, maybe. This is a 1-6 pair here in box 9. That forces this not to be 1 or 6. It's 7 or 9. Where is the 6 in box 8 then? It has to be here. This is also 1 or 6, so that doesn't really help much. Okay. 7s. Don't have much information. 8s. Where is the 8 in column 3? Can't be here because of 8's in the row. Can't be here because of 8 in the row, and the rest are filled out, so 8 has to be there. That eliminates 8 from being there. Not enough information, though. 9. Okay. Remaining digits. In row 5, we have 7 and 9. The remaining digits in row 6, we have 1, 6, and 7. This can't be 6 because of 6 in the column. This can't be 1 because of 1 in the column. 6 cannot be on this diagonal anymore because of the envious arrow. So that's 7, which makes that 9, which makes that 1. So then this is satisfied. 1 and 9 eliminate 1 and 9 here. It's 7, which eliminates 7 there, so it's 9 and 7. 9 eliminates 9 here, so it's 1. These can't be 7 anymore because of 7 in the box. 7 eliminates 7 here, so it's 9, which makes this 7. 1 and 7 here, eliminate 1 and 7 here, so it's 6, which makes this 1 and 6. 6 also eliminates 6 there, so that's 1. 9 eliminates 9 here, so it's 7, which makes that a 9. We have 6 and 8 left here. This can't be 6 because of 6 in the column, so that's 8, that's 6. 8 eliminates 8 here, so it's 9 and 8, and 9 eliminates 9 here, so it's 7 and 9. And that's this solution. Pretty cool. Very interesting how the envious and selfish arrows acted with each other. Yeah, overall flowed very well. It was very nicely put together. And I enjoyed it. Anyways, I hope you enjoyed the solve, and I'll see you next time on Frank Puzzles. Take care.